So 9-3 bar graphs and dot plots. So this should be some kind of a little bit of a review. You should have seen a bar graph before. And then you should have seen a dot plot before. There's a couple of questions on this that I don't really love, so we're going to kind of reword them. But we're going to talk about all of them for a minute. A bar graph is a type of graph that shows the number of items in a specific category. So like right here, it tells that they asked people, they surveyed some people, and then they told them what kind of their favorite ice cream was. And those are the responses that they got. So they asked 100 people, and then they got vanilla is 24, chocolate is 26, strawberry is 12, mint is 22, and berry is 16. So they got all those responses. So it says determine the number of people surveyed. So they added up all of those numbers that we just talked about. Okay, they added 24, 22, 26, 12, 22, and 16 and got 100. So that's the 100 people that they surveyed. Okay, and it says divide. So it's asking to use the bar graph to compare the total number of people surveyed to those who chose berry. So that's kind of backwards because they're saying total to berry, okay? So total is not usually always first, but sometimes it is, so you need to make sure you're paying attention to the wording. So total would be 100, and berry would be 16, and then they divided it right here to go ahead and get down to the decimal percentage. We're not going to do that. I'm not worried about that as much on this. We're going to look for percents maybe here in a bit. Okay, this is a dot plot. A dot plot is a graph that shows the frequency of a set of data with a number line, okay? And it says both types of these graphs can be used to make a part-to-whole comparison. So usually it's a part-to-whole. Usually this is a wordy question on your unit test. This is a wordy question on the star. You just have to really pay attention to what it's asking. So the dot plot shows the number of free throws made by members of the basketball team during their last game. What fraction of the total number of players made 2 or less free throws? Okay, so fraction of the 2 or less. So does that include 2? 2 or less? Does it include 2? Yes, so 2 or less would be this one, and this one, because those are all 2 or less. So that is 2, 3, 4, 5 out of 6, 7, 8, 9, 10 total free throws. So 5 out of 10 people made 2 or less free throws, which that reduces to 1/2. There are a total of 5 players with less than or equal to 2 free throws and a total of 10 players on the team. So that's how they got that. Okay, so let's scoot on down. Use the bar graph from example 1. So this is example 1 up here. To compare the number of people who chose vanilla to the number of people who chose strawberry. So we're just straight comparing vanilla to strawberry, right? So I'm going to do vanilla is 24. Strawberry is 12. Okay, so twice as many people chose vanilla than strawberry. Did you see where I get that reference? Because 24 times. If I reduce that, I would say 2 to 1. It's pretty much a 2 to 1 ratio. Okay. Number 2, the dot plot shows the number of times per week that a group of students use a fitness center. How many more? What does how many more mean? Yes, you're right. It means what? Subtract. How many more means I'm going to subtract at some point. Okay. Students use the center 3 or more times a week. Then students use the center less than 2. Okay. So greater than 3 or equal to 3 or less than 2. We're going to subtract those. Does that make sense? So what's greater than or equal to 3? How many is that?
21.
3, 4, 5. So 4, 8, and 11, right? So there's 11 on that. And then how many do 2 times, less than 2 times? Is less than 2 equal to? No, so it's just less than 2. So it would be 1 and 0. So that's 2. So 11 minus 2, because it's how many more? Which would be 9 more people. Okay, are we pretty okay with that?
Yes.
Okay, let's look. The page. Did we lose it? Oh man. Okay, so we're gonna say that I had to scoot it over, so this may changed the video just a little bit, but everybody else's should be good. The bar graph shows the total number of pets. Okay, that the students in Mr. Murphy's class own. Okay, the first one says, what fraction, oops, I didn't need that one, I needed the highlighter, of the total number of students owns one pet. So we're looking for one pet to total. Okay, how many own one pet? Well, that's 10, right? Yes? You all agree with that? Mm-hmm. Out of the total, well, 10, this is 6, plus 10, plus 5, plus 2, plus 1. So that's 16, 21, 22, 23, 24 total. So 10 out of 24 own one pet. Can I reduce that? They're both divisible by 2, so we reduce to 5/16. I'm sorry, not 5/16, 5/12. I'm sorry. Okay. Number 4, compare the number of students that own no pets. So we want no pets. And I can write it as a fraction. Remember, I can write things as a fraction this way. So like 1 to 2, 1 to 2, or 1. You can write it all those ways. Remember, you can write something like that. So no pets to, I like fraction form. That's my personal preference. To the number of students that own 3 pets. So no pets is how many? 6, right? And then 3 pets is 2. So if I could break that down just a little bit more, I would say 3 times as many people own or don't have any pets versus that have 3 pets. So I need to be able to take it and make an inference with it. Like I need to be able to say, okay, hey, this means this. So 3 times as many people have no pets as they do 3 pets. Number 5, what fraction of the total number of students owns more than 2? More than 2 would not include 2. So it would just be 3 and 4, which is 3 total pets. And of the total number, so we need greater than 2 out of total. So the total is 24. Can I reduce that? Mm-hmm. To 1/8. And number 6, compare the total number of students to the number of students owning 2 pets. Okay, so compare the total number of students to the number of students total 2 equals to 2, right? So what's the total again? 24. How many just have 2? It's this category right here, which is 5. I can't simplify that any more than it is. Are we getting the hang of this okay? Yes. Okay, the dot plot. What fraction of the families uses one computer? Well, one computer is right here. There's 3 of them out of how many total? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Express it in simplest form. That's in simplest form. What fraction of the families uses either 2 or 3? Well, 2 or 3 would be this one and this one, which would be 8 out of 13 computers, and that's in simplest form. Not too bad, right? Compare the number of families that use 2 computers to the number of families that use 0 or 4. So 2 to 0 or 4. So 2 is 4. 0 or 4 is 2. I can reduce that to 2 to 1. Hey.
Would it be the same? It says or 4 or not.
So it can include either one. So you add them together. Number 10, compare the total number of families to the number of families that use less than 2. So total is 13, and less than 2 does not include 2, so it's 0 and 1, so that is 4, and that cannot be reduced. And what fraction of the families use at least 2? So that's 2, 3, and 4, which is 9/13. Okay, I want to talk about one more thing, and it's not on here, but you're going to see it here in a minute. It's going to ask for a percentage. Okay, the way you're going to find these percentages is you're going to do part whole. Percent 100 is over a percent 100, whatever. You remember we've done that before. Mm-hmm. So you're going to have to compare and find that percentage using this formula or this, proportion. Okay, so if it asks you for a percentage, you're going to have to say, okay, what are we looking for out of what we have? What's the percent out of 100? And you remember how to do that is cross multiply and divide. So there is a percentage one on your homework.